Heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
All right, good evening and welcome everyone to Mount Washington Observatory's Science in the Mountains lecture series presented by Northway Bank. My name is Brian Fitzgerald and I'm the Director of Education here at the Observatory. And joining us this evening to tell us all about the Northeast Regional Climate Center located at Cornell University is Art DeGaetano. Thanks for joining for tonight's program. If you're not already familiar with the Observatory, we are a nonprofit member-supported organization with a mission to advance the understanding of the natural systems that create Earth's weather and climate. And we accomplish that through operating our Summit weather station with around-the-clock weather observation and forecasting, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have questions for tonight's speaker and you're joining through Zoom, please be sure to use the Q&A button that can be found at the bottom of your Zoom toolbar. We'll take questions at any point tonight, but we'll make sure to save time at the end for our live Q&A session. If you're joining or watching via recording or through Facebook, please feel free to join us for a live program next time, and you can register over at mountwashington.org. All right, well, before we get going here this evening, I want to launch a quick poll for those of us who are attending here. So if you're joining through Zoom, you should see some poll questions popping up in your screen right about now. Just 3 questions for you tonight. The first one, we're always curious where folks are joining from tonight, whether or not you're joining from a state within New England, perhaps you're joining from outside of New England, maybe a neighboring state in the region, or perhaps from even outside the country. Let us know. And then 2 questions from tonight's speaker. The first one being, climate-based decisions rely on what? Historical data only, past observations and future model projections, weather forecasts, or just answers B and C, past observations and future model projections and weather forecasts. And then finally, a good Mount Washington trivia question here. Temperatures that are below 0 degrees Fahrenheit have occurred on Mount Washington in what months? In all months but July, in all months but June, July, and August, in all months but June, July, and September, or all months but June, July, May, June, July, and August. And I may have even flubbed on that third response there too. Good trivia question tonight. I'll be the first one to admit I don't know the answer to that last one. I'm very curious. So get your answers in there. I'll give you just a few more seconds. I see many of you have already responded. And we'll close the poll here in 3, 2, 1. All righty, we'll end the poll and we'll share some results out. It looks like we have some great representation once again from New Hampshire, with 1/3 of you joining from the Granite State. Good representation from every state within New England, and then a little more than 15% of you joining from outside of New England as well. So great welcome to everybody, regardless of where you're joining from. Question number 2, many people chose either past observations and future model projections, or answers B and C, basically that one, and weather forecasts. And then finally, a little bit more of a split for answer number 3, but most of you said temperatures below 0 have occurred on Mount Washington in all months but July. 63% of you said that one. All right, well, we will find out the answer and more here in just 1 minute, because I'm going to stop sharing the results there. And at this time, I'd love to welcome tonight's speaker, Art DeGaetano. Art, are you there? Can you see me? Can you hear me? All right, I can see you, but I cannot hear you just yet.
There it goes. Sorry about that. Missed the click.
You got it. Well, perfect. Hey, Art, thanks so much for joining us tonight. Really appreciate it. And without further ado, I'd love for you to take it away.
All right. I mean, should I hop into those questions first? I guess you're keeping people on, on their toes.
That is totally up to you. Although
All
I have to say, I am very curious. So if you could give some answers,
All
I'd
right.
love it.
Yeah, I would say most people got the first one right. You'll see in a lot of our products that we're going to talk about, they're a blend of historical observations, climate model projections of the future, and actually weather forecasts, because a lot of the decisions are real time and it requires what has just happened and what's going to happen in the near future.
Okay.
And then in terms of the Mount Washington question, I want to know, Brian, what would your answer have been?
Oh no, putting me on the spot
I
here.
am.
Oh,
And
if
I'll
I
admit, I
have,
didn't know when I came up with it last night. So.
uh, you, hmm. Boy, I really went back and forth on the month of May. I thought, I wonder if we've had a below zero in May or not.
Yeah.
I'm gonna say, I'm gonna say it's the May through September answer.
Yeah, May through September wasn't the one of
Oh no, all right, we might have lost you for a second.
that extended period there.
Oh, Art, it looks like your connection went
Could we
perhaps bad for a
please?
second there.
All right. So I did say, no, May had below zero, but September did not. So the summer months plus September have not been below zero on Mount Washington.
That was a tricky one. Great
Yeah,
question.
like I said, I didn't know the answer either when I thought it up. So I was surprised. I was actually surprised.
Yeah. Oh,
I,
awesome.
I think
Well,
I would have went with
you've already
most of I would have went probably with July, like most of the respondents did.
yeah. Well, you've already piqued at least my interest, so please tell us more.
All right, let me get my share going here. All right. So, like Brian said, I'm Art DeGaetano. I'm the director of the Northeast Regional Climate Center, which is at Cornell. The Climate Center is actually part of a program. We're funded through NOAA, and just last year we celebrated our 40th anniversary. So we've been a pretty long-standing program. My colleagues, my sister centers are scattered about the country. You can see most of these are at land grant colleges like Cornell. So the Midwestern centers at Purdue, and the Southeast Center is at actually University of North Carolina. High Plains is in Lincoln. So we pretty much have an academic partnership in each of our centers. Um, so really, why do these centers exist? Really, our mission kind of falls into a few areas, and I mean, you can read that yourself. But we do a lot of work with data, collecting data, disseminating data, getting that data out to people so that it is usable in their decisions. We do a lot of monitoring conditions. So this is kind of our real-time role. We're quite heavily involved in drought monitoring. But really, one of the keystones of our monitoring program is our ability to be nimble. And I don't think I have it as an example in my talk today, but a good example of that is, if you remember, not this past summer, but the summer before, when we were quite smoky here in the Northeast from the fires in Canada. We actually embarked on a project with some public health people to not only monitor air quality, but tie that to a NOAA product that shows where the wildfire smoke plumes are. So we're able to do some monitoring of health conditions that are exacerbated by wildfire smoke. We work closely with our partners in NOAA. A lot of the NOAA data services actually come through us. And then a lot of our work, since we're all at academic institutions, is to do applied research and have that research factor into the types of products that we give out to our users. So I think more simply, what we do is take lots of data and turn it into information. The backbone of our data services are a system that we call ASIS. And again, lots and lots of computers increasingly moving on the cloud. But the idea here is that the data sets that we store can get merged. Software can be applied to it, and we can use that system to answer user requests. There's a whole laundry list of different data sets that we include in our data services and our data sets, from station data, from the national network, the Global Historical Climate Network. Sometimes that's referred to as the co-op network. COCO-RAS is the Citizen Science Rain Gauge Network across the country, actually across the country and into Canada. We collect data from them. A number of USDA networks feed their data into our system. We are embarking on actually an ambitious project where we're starting to bring in the hourly record for the country for all the ASOSs, all the stations that the federal government supports in hourly data. And in addition to that, we've had a long history of bringing in data from state and regional mesonets, and kind of that's just a smattering of states that we collect data from. Saw some Maine people up there, and that's probably going to be the next state that we're partnering with as they establish a mesonet. A lot of our data sets are gridded, so we don't only have to rely on a station, but we can pretty much look across counties, look at any points on a map and things like that. And that's a blend of gridded station data, some radar data comes into play there, things along those lines. Projections from the most recent climate models. And then under the acronyms there, those are actually gridded forecast databases. So that kind of goes to the poll question where in a lot of cases we need to bring in weather forecast data in some of our products. So have a URL there, and really this scasis.rccasis.org site is a fairly user-friendly site. It's maybe a little bit more sophisticated than some of our simpler sites, but it's a good way to access many of our station holdings. And I'm going to do a few examples of that through the rest of my talk, or at least the first part of my talk. So of course, picking on Mount Washington, these are our data holdings from Mount Washington. The observatory itself might have some additional data. These are the parts of that data record that are in the federal network, in the co-op network, in the World Meteorological Organization network. So at least there, right now, that data going back to 1948 and right up through to present. I actually put together my talk on the 8th. If I did it today, that data would be current right on through today. Actually, if we were looking at the hourly data, it would be current right up until the last hour. So really try hard to get the data in as soon as we can in real time. So a little bit of a tour. The way this site is arranged, there's a number of different products. And basically what those do is say, are we working on a single station, on many stations, or using some of our gridded products? So I'm giving an example here of a single station product. And the type of summary I want is the time series for the day. Like I said, I'm working on Mount Washington as a station. I did my talk on the 8th, so I chose the 8th of January. And basically what you see here is going back in time. Pretty much the weather observations for any day, any January 8th going back in time. So you can see a balmy -20 back in 1954, actually popped up just to freezing in 1956 for the high. Some pretty good rainfall totals there too, actually, for January day, over 2 inches back in 1958. Our tables and a lot of the products here are very interactive, so I can click on a heading for the table and sort it. So now those temperatures, I clicked on the minimum temperature column, so now that column gets sorted from the coldest to the warmest. So you can see I believe in that 1948 to present record, that's the coldest temperature reported at Mount Washington in the NOAA network. Can kind of click on some other products. I'm going to show the almanac for the day. And really there, I picked Christmas, and basically it's any given day, and you can see, for a particular year, what was observed. This was Christmas of this year, what the normals are, what the record high and lows are, some month-to-date statistics, some year-to-date statistics. So really just a good summary for the data on a given day. We affectionately call this piece of software our wedding planner program, because quite often people will call us and say, oh, what's the best day to have my wedding? What's the least chance that it's going to rain or something like that? And a product like this can kind of give them that information. Useful for figuring out the probability of things like a white Christmas as well. Have a lot of graphical products on this site. So again, I've same thing, but I've selected a time series for the day in the graph. And this is where you can really customize the products, and that's really one of the attributes of a lot of our systems. I should say this is all computerized now, but we really had the idea of this way back when, kind of early in our 40-year history, where all of our questions were answered over the phone. So that actually provided us with quite a wealth of information on the types of questions people ask about the weather and climate conditions, what they use those for. And that kind of has helped us guide our products. So here I'm showing temperatures on Mount Washington averaged for the meteorological winter from December to February, going across the period of record. I'm able to put a running mean on that graph, the black line, the individual years there in the blue, and I've chose to do a simple linear regression, all done on the graph there. So we can see the rising temperatures through time. At Mount Washington, we can see the coldest winter temperature on record here, and I guess that's 1977. And basically, I guess the warmest year on record just last year in this data series. Same type of thing. There's also charts for this. They can be sorted if you want to not see things chronologically, but sorted from high to low. Oops, there it is there. So again, high to low last year was the warmest on average. And notice there in the top 10, lots of 2000s. So kind of there, another example of the warmest years on record being within the last decade or so. Here's winter snowfall on Mount Washington, again, through winter. Not much of a trend there, actually. You can see the highs and lows, and it's kind of showing this as an example of some of the other types of data sets that we can present. A lot of our monitoring has to do with runs of days. This is very important in the urban centers that we serve in terms of heat waves and things like that. So, or we can also do this with cold. So I've chosen days with a minimum temperature less than 0 degrees. I want to look over the period of record, and I want to get the top 10 longest runs. So that's what I've selected there. Could have made that any number if I wanted to. And we can see the longest run of days below 0, or days with a minimum temperature below 0, occurred in 1989, where there was a run ending just at the end of December. So that whole month of December basically was below 0.
Hey, Art, I hate to interrupt, but just a point of clarification: are most of the temperatures you're talking about and working with typically in Fahrenheit?
Yes, actually, in any of our products, we are working with Fahrenheit. So yeah, I should have, I neglected that. That should be 0 degrees F. It is possible to change scales and look at products in C if that's what a user wants.
Well, we'll credit our participant Rena for that great question,
Nope.
but I figured it was a good one to ask right now. Anyway,
That's a
sorry for the
perfect one to ask
interruption.
Yep, no problem. First last dates, what was the first occurrence of something? We use this a lot for ag with figuring out the frost season. Here I've tweaked it a little bit and I've made it snow depth. So this is the first and last occurrences of days with greater or of an inch or more of snow on the ground. My years are a little funky to cross over the winter season. So I don't want to start in January and kind of break up a year. So I have a year running from August 1st. That's that period beginning. And you can see here the, kind of the records. I think I've sorted it by, I forget what I sorted it by. I think the last date actually. So as an example here in 1948, well, maybe I didn't sort it. This looks chronological, but again, I was surprised when I looked at this, some of the stretches of days with more than an inch of snow on the ground in at Mount Washington. Basically starting in October or starting in September and not ending through June. Guess I should have realized that, but I found this kind of surprising, having over 250 days with an inch or more of snow on the ground. I'm sure Brian can attest to that. Here's where I can sort it so you can kind of see kind of the earliest first day of an inch of snow in August, and the latest I've sorted it on the first, but the latest here in many cases in June. And then actually in this table, if you scroll all the way down to the end, there's some summary statistics. So we can see the earliest date being in August 30th, the latest date being July 2nd, and the length of number of days in those seasons that had snow on the ground. A lot of our monitoring for drought deals with accumulation. So here I'm looking at rainfall at Mount Washington over I guess I'm looking at year to date for this current year. So this goes from January 1st through December 31st of this year. And the way this graph is kind of set up is the green line in the green area is normal. So you would expect rainfall to accumulate kind of along this green line to the season, obviously starting zero at January and then accumulating up to about a normal of, it's like just shy of 90 inches or around 90 inches over the year. The brown line is the current season. So we can see this season at Mount Washington was pretty darn close to normal. Maybe a little bit dry early on from March in through October, but then picking it up and kind of ending right at normal. The blue line is the maximum accumulation in any year of the record. And the pink line is a year that was fairly low. I chose 1965 during the kind of the Northeast drought year. We can look at stations across a region. So I can perhaps say if I'm interested in the state of New Hampshire and want to see what the lowest average temperature was in a given year, I could do that. And I get a response that looks like this. So these are all active stations in New Hampshire. Looks like Mount Washington wins out to have the coldest maximum temperature. But you can see any number of stations that are definitely below zero in this case. Kind of look at the different networks they come from as well, the main airports and the co-op networks. Our gridded products, there we're able to maybe do averages for counties, so we can look at all the grids in the county and sum some up. So I've looked at monthly precipitation over this past summer for the counties in New Hampshire, and you can see what the output for that looks like. So this goes, we use products like this quite a bit in our drought monitoring products, both nationally for the drought monitor and our work for the drought task force in actually all of the states in New England and New York included. Our gridded products can be used to produce maps. So here I have a map of total rainfall from, I guess, this summer across New Hampshire. You can see the highs and the lows. I'm able to set the contour level. So if I want to have wider bands or lower bands, I can do that and have more colors if I want. The product I've chosen is actually a radar-based product, so it combines station and radar. And that might be the question on why there's some pieces missing along the borders because of poor radar coverage coming from our neighbors to the north. And then hourly products. Like I said, this is our newest, the newest types of products that we've been working with NOAA on. So here's an example of a program that can be used to generate windroses. So again, I'm looking at not the whole period of record, but several, about looks like about a 30-year period. Of wind speeds. So I basically can set the station I want and the periods and a bunch of other things, intervals. I want the whole year, how I want the compass set up, what units I might choose. I'm working in miles per hour here. And then if I hit go on a product like this, I generate a windrose. So here's the windrose from Mount Washington. Basically, if you're not familiar with windroses, how far out you are on the circle says what percentage of the time the wind comes from that direction. So in this case, the predominant wind directions at Mount Washington are coming from these kind of western sectors between 280 and 310 degrees. And then the different colors kind of give you an idea of the wind speeds. So in this case, the greater than 45-mile-an-hour barb is this one far out there. That's unusual for most windroses. Usually the outer bands are quite small in their frequency, but at a place like Mount Washington, these high winds are quite common, particularly from the west. It's kind of an ugly slide, and I'm kind of just using it as an example and particularly to perhaps pique the interest of any data geeks out there. Really, the way that any of these websites work is through something that's called a web API, a web service. So many of these requests are programmable. Many of our users don't use our websites, but actually come directly into our database and use that to generate their own graphics, use that to populate their own websites, things like that. Many of the news organizations do this. If anybody's familiar with Climate Central, a lot of their graphics are based on our database and they're programming directly to it. So not only are we catering to kind of the lay climate or weather enthusiasts, but also to maybe some more of the more sophisticated users of climate information. And again, going to shift gears. As I said earlier, we partner with many federal agencies. So I've pulled up the National Weather Service Boston's website. And if you go across their tabs, there's something that's called Now Data, and that's how the Weather Service offices, that's the app they kind of use to present their climate data. And if your eyes are pretty keen, you can see that this is powered by ACES. So this is actually an app that we manage for every weather service office across the country. So whether you're in Boston or out in Washington or California, all of those requests are coming to Cornell and being supplied by the Northeast Climate Center. We do a lot of user-specific monitoring, and I have a few examples here of products, kind of map-based products. The one on the left where we're focused in on Maine is probably an interesting one given the audience. Over the years, we've worked quite closely with the Maine DOT, and the problem that they address is during the winter time, they allow trucks to carry heavier loads because the roads are frozen and they can support more weight. But then as spring comes along, they need to know when the roads begin to thaw because they need to give the trucking companies kind of a heads up on when they have to cut back on the weights that they're allowed to carry. So basically, we have a model that pretty much uses air temperature to derive this freezing index. What Maine wanted us to do is use this real ugly pink color that's covering most of the northern part of the state, so it really stands out. That's where the roads are or were sufficiently frozen to have these weight premiums put into place. And then as time goes on and we move into spring or we hit a warm spell, there's an associated thawing index, and that would tell the state when they need to remove these premiums. And if you notice the app, there's these forecast days. That's where bringing in this weather forecast data to the kind of climate decisions becomes very important. The state of Maine can't just say, nope, oh, nope, today got to have lighter loads. They have to give the trucking companies a little bit of heads up. And so we're able to generate this index and project it out 5 or 6 days into the future. A lot of our other products are agriculture related. So kind of maybe a New York specific example, although Vermont as well, has to do with the risk of frost to the apple industry in the spring. So basically in the upper right, during a given spring, we can monitor the conditions, how far along the apples are towards bloom. If I had the animation going, you could see that wave of, say, full bloom or green tip stage kind of migrating across the region. And then more importantly, what they're interested in on any given day, if you reach one of these stages, what is the probability historically that the apples would be damaged by an untimely frost? So the farmers look at this quite closely in the spring, and then kind of over a longer climatological time period, actually the data that we've used to generate these things historically has been used by the insurance industry to set their rates for crop insurance dealing with frost risk in fruit crops. Most of our work is stakeholder driven. So we've done a lot of work with extreme rainfall and changes in extreme rainfall. So this is an example. A lot of engineers use this idea of a 100-year storm. The only problem with that is the 100-year storm changes through time, given the increase in extreme rainfall that climate change has brought about. So with a tool like this, we're actually able to monitor these types of changes. This work was actually driven quite a bit by the state of New York in wanting to update their statistics for that. But we've since worked with many states across not only the Northeast, but the Mid-Atlantic. We have climate change or climate projections in our data, so we're able to kind of put things in a changing perspective. So here's an example of looking at trends in historic data across the region. I'm picking a minimum temperature, and the colored counties there represent what the trend has been from 1980. In this data set through 2013, actually, this is about to get updated to the new normal period through 2023. But you can see in this period of time, the trend has been over almost 3/4 of a degree over that looks like almost 30-year period of time. If you click on a county, you can also see the projections for that county. So I've clicked on, I assume it's Coast County in New Hampshire, and looking at, again, this average low temperature for the year. And what this is showing here is the black dots are the observations, and the green line and the green shading are what climate models are projecting that temperature to look like all the way out to 2100. If you kind of look down at the bottom part of the graph, we have the observed period. That is kind of intended to show that the models do a good job of simulating the observed climate. The black dots fall within the green band, and then going into the future, how that's going to change. In the upper graph, I've chosen an emission scenario where there's very high emissions, actually probably an emission scenario that's a bit higher than what we currently see. So this probably now would be called very high emissions. And kind of the way to read that is in the historical period, this average low temperature over the year was about 28 degrees. And if we went out to the end of the century, it would be about 40 degrees. So about 10 degrees Fahrenheit warmer under this very high emissions global warming scenario. The bottom graph shows a more modest emission scenario probably attracts somewhat what we're on right now. But even there, we see this 28-degree maybe average in the historical period, ending up, maybe right around 35 degrees Fahrenheit. So still an appreciable rise of about 7 degrees Fahrenheit. Um, our work with climate change projections extends to rainfall. So here's an example of a river basin commission that's basically across the western parts of Pennsylvania into New Jersey, Delaware, and the upper reaches of the Delaware in New York. And tools like this are used in engineering design for bridge heights, culvert design, things along those lines. And really what we've done here in working with the users is to take the current engineering standards that NOAA puts out. It's called Atlas 14. If you're an engineer and you're building something, you use that Atlas 14 data quite a bit to get things like the 100-year storm or the 50-year storm. The only problem is that's based on historical data, past data. It doesn't take the change into play. And through this product, we're able to look forward and see how these engineering design statistics are going to change through time. And kind of the graphic here is what the engineers use. But the idea here is maybe the better way to look at it is I've picked this county in Pennsylvania, and really what it says is by the end of the century, the current designs for the 100-year storm will need to be increased. That's what this change factor is, by almost 25%. You'd need to multiply the current value by 1.22. So really to kind of wrap up and open it up to some questions soon, I invite you to check out our website. I think you'll find a lot of neat things. We update our blog quite frequently. I think Sam does it on the order of at least twice a month, perhaps more often if something very interesting is happening. So this was our current one, which summarizes the year 2024, the end of the year. If you're big on webinars, we also have a webinar series, basically do a webinar each month. You can see the upcoming dates there down at the bottom. You need to register for it. And the way our webinars work is basically the first part of the webinar, maybe the first 20 minutes or so, is a summary of weather conditions during the previous month. And then there's a different topic of discussion for the remainder of the webinar. So our last one was on an update on El Nino conditions, ENSO conditions, and an outlook for the winter season. The next one is more of maybe an applied type research or product seminar or webinar on how the insurance industry uses climate data. Anybody want to fill in for February? I guess that's still TBD. And then typically in March, we have a spring flood outlook from NOAA. So that will be our webinar there. Summer comes along, kind of May or June, we'll have our hurricane outlook webinar. That's typically also very, very popular. Also, each quarter we put out an outlook, and basically the outlook is maybe a misnomer. It's kind of a recap on one side and an outlook for the coming season on the other side. It talks about a lot of the severe weather events, talks about a lot of the impacts, typically a focus on something that has happened significantly across the region, often on land, but also on the sea. We also, do things in the Gulf of Maine and look at ocean heat waves and things along those lines. You kind of see we do 3 outlooks. One is focused primarily on the Gulf of Maine region. That also extends up into Canada. That might be of most interest to folks in New Hampshire, but then our broader ones cover what we consider the Northeast, and we team with our partner in the Midwest to look at the Great Lakes Basin. So I think with that, that's what I have for tonight from snowy Ithaca, New York, at Cornell University.
Well, thanks so much, Art. That's excellent. I really appreciate that. And I know I already have at least a few questions myself, but I'd love to welcome all of our viewers here to submit any questions that you may have for Art. We'll try and get to as many questions as we can here. I know we have at least one that's already pending right now. And I mean, actually, the first one, just before I get to other questions here, Art, maybe I missed it a little bit, but that kind of piqued my interest in that you have both some information, both sort of a recap and outlook for waterways. So like you're showing the Great Lakes and also the Gulf of Maine region there. I mean, are there other products and say industries that have interest in some of the information that you're making sense of, in both fresh and saltwater environments?
Yeah, I would say the saltwater environment is something we've been branching out more to in recent years. Trying to actually, it goes back at the federal level. Actually, the what used to be the National Climatic Data Center has kind of merged a number of data centers together, which includes all the oceanic information. So we've started to work with them in a lot of cases to look at some oceanic type type products and things like that. We're actually working on a project actively right now with actually the fishing industry and trying to come up with a storminess index. So they're trying to use that as a gauge for whether if there have been fewer days that in a given year or season that the fishing fleet may not have been able to go out, and looking at that both in terms of commercial and recreational fishing.
Oh, fascinating. Okay. Yeah, definitely learned at least one new thing here this evening. Well, Art, there's some other great questions here, including, well, at least a couple here from Rick, who asked a good question, stating, I'm interested in changes in extreme and variable climate. Your graphs that you showed started in 1950 in some cases, but the 1930s were so extreme, and I want to include some of those as well. Can I use some of those years starting that far back? And I guess I'll even broaden that question further for Rick. What are some of the periods of record that your climate center has
Yeah.
access to?
Yeah. Our period, as long as there is a period of record at a station, we have that. If I chose the Ithaca record to base my talk on, the Ithaca record goes back to the 1880s, so I could easily show a time series going back there. So in a lot of cases, we're kind of constrained with when did these weather stations operate, and when do they have data available to us. We have many stations in our repository that go back to the most definitely the early 1900s, and in a lot of cases the late 1800s. We've worked on several projects through our history to actually kind of resurrect old data. My colleagues in the Midwest, there were some data sets from old forts out there, and they were able to go back into the much deeper into the 1800s. We have some hourly data records from places like the Washington Naval Observatory, where you could actually see the hourly data on the day Lincoln was inaugurated. So it really varies from station to station.
Oh, amazing. Yes. And I had to laugh with Mount Washington going back to 1948 in your records. It made me think of the World War II years in which meteorological data was a matter of national security. So in many cases, observatory data wasn't let out to the public,
Yeah.
let alone climate centers. So makes
Yeah.
me wonder if those were some of the limitations there.
Yeah, I actually wondered about that when I did my talk. I was surprised that Mount Washington only started in 48, but that's a common starting point for a lot of the kind of hourly, you have an ASOS up there, so stations like that did hourly observations for NOAA, that's quite common.
Well, I know we have more data than that, and we'll be happy to
We'll
send it
have to
your
get it
way.
from you and put it in our database. I don't know if
It's a deal. Well, some other questions here. Catherine was curious about the webinars, which I look absolutely excellent. Curious if you, other staff, who's generally presenting across some of those webinars?
Yeah, well, actually, the one who does the summary is one of our service climatologists, Sam. She does a wonderful job. A former broadcast meteorologist, so she does that. And then the second parts, it varies. We have a different speaker each month, either somebody from NOAA, one of the partner agencies we work with, just basically a topic of interest. And we also, after each webinars, kind of invite our viewers to kind of give us ideas on things they might like to hear about. So we're quite responsive to things like that.
Oh, I love it. And correct me if I'm wrong. Is Sam also the individual who produces your blog, or is that someone else?
Sam is our blogger, yes.
Well, we spoke prior to this, and as someone who helps run our cooperative weather station here in town, I mentioned that it's always great trying to put together a summary of climate conditions here, even in North Conway, and in comparison what's going on with the rest of the Northeast. And for anyone who's ever interested in sort of the look back of what's happened over the past month or season or what have you, I think a lot of the products you mentioned, but that blog in particular too is great to look at sort of all the climate stations across the region and see how some of these things stack up. So big shout
Yeah.
out there.
Yeah, we hear that from a lot of people. They like that perspective and kind of like that, who are in the top 10, who are in the bottom 10, that kind of stuff.
That's all right. Yeah, that fun stuff. Well, all right, another question here from Mary, who's curious if there are any specific data sets that you're aware of that are used by the FAA, so the Federal Aviation Administration, and how maybe aviation comes into play in any of this?
Yeah, a lot of the hourly data record that we have is actually used by the FAA. Most of those hourly stations, most of those hourly NOAA stations are airport based. And I would say through history, the prime reason for there being weather stations there is aviation and support the FAA. Actually, in some cases, climate kind of takes a back seat to that. As a good example of that is clouds. Basically airport operations rely really just on low clouds. They really don't care about upper level clouds. And as they've changed their instrumentation through time, we've kind of lost those high cloud records from human observers that would really be quite useful from a climate perspective. So yeah, historically, most of the hourly weather data that we have is for aviation, is in support of FAA. Increasingly state mesonets and things like that have come into play, so that has expanded our hourly data. And again, most of those networks also have specific purposes. So either
Yeah.
ag purposes or water utilities, water, drought monitoring, things like that.
Yeah, and I bet with your products, I'm sure an airport could look back at its own data, perhaps for just how weather has and climate has operationally maybe impacted some of their transportation and schedule, and compare that with some of their operating schedules and things like that.
Yep, most definitely.
Oh, interesting. Um, Lotus asks a question here, saying, Art, you mentioned about New York becoming interested in water levels, I believe it is. And I was just curious, was that in response to Hurricane Sandy? I remember how shocking it was to see parts of New York City, New York, and even New Jersey going under so much water during that hurricane.
Yeah, I mean, New York, I mean, not water levels, but basically rainfall, extreme rainfall intensities and things like that. And really, Sandy, Irene, I mean, I can start to rattle off a number of storms. And then actually the thing that really has piqued New York City's interest was Ida back a few years ago, where that was
Mhm.
just a dramatic rainfall event for the city, unheard of hourly rainfall intensities. Many people dying in basements because basements flooded because storm sewers weren't able to handle that volume of water. So they've really started to look at that a lot more intently, basically, particularly looking at rainfall on those hourly records where there really isn't a good amount of data for. So, um, been kind of trying to do a lot of things with radar and the available data to get a handle on how these hourly rainfall events have been changing in intensity, or should probably say if they've been changing in intensity, because or if they've been changing in intensity any more or less than the daily values. So um, that's a very active area of research, and again, in response to a number of big flooding events in the last 20 years or so.
Yeah, and then that makes me, I mean, all the more curious about your upcoming webinar talking about the insurance industry, and certainly makes me curious about how your products potentially are used in any sort of disaster relief and funding that goes toward those areas. And obviously, think of things like current wildfire, happening in Los Angeles and elsewhere, and eventually probably a look back at what conditions probably were like. And I can think in some cases where folks have reached out even in our direction, I think maybe from the USDA, asking about disaster relief during drought scenarios, perhaps for agriculture and livestock and things like that. Does that come up for your office?
Yeah, I mean, definitely our data, I would say it's one of the main sources of data that drives the disaster declarations for drought. It feeds directly into the drought monitor, and those drought monitor categories are the things that kind of trigger that. People use our data quite a bit in developing hazard mitigation plans for their communities. That's something that's required by FEMA. Basically, if you haven't filed a plan like that with FEMA, you're pretty much, SOL if you're coming for disaster assistance and things like that. So we provide that type of data for communities that are doing these types of plans, engineering firms that are working with communities to do these types of plans, things along those lines. The reinsurance industry is really interesting because, man, they're really taking this, up several notches and really doing some really sophisticated hurricane modeling, taking a hurricane that, maybe hit North Carolina and then playing out a scenario what it would have looked like if it hit New England or Long Island or things like that. So they're really interested in these changes and risk at that level, particularly the reinsurers.
I bet, and what that means for the rest of us, well, I don't know, but
I don't know. I wouldn't like to be in California looking for insurance right now.
no, and other coastal and other flood
Yeah.
prone regions, certainly tough business to be sure. Maybe just one more question here, Art. I really appreciate you sticking around a little bit. Catherine asks another great question that love to just kind of lift once again. Who's curious about are the hourly data and the products on the public SC-Axis website basically available? If so, where? I'm not exactly sure specifically what Catherine might be talking about.
Yeah. So I looked on the, tell Kathy she should just call the climate center because she used to work there. So that she's my seed question there. Um,
I had a feeling.
yeah, we talked about that beforehand, Kathy. I knew you'd be on there. So yeah, you can get it through SC ACES actually. It's not quite public yet, but if you stick a dash test after SC ACES, you should be able to see those hourly products. It's a functional website, but really haven't really released it to prime time yet. So that SC ACES dash test kind of as all one word in that URL, and you should be able to find it.
Oh, excellent. Well, if you ever need some comparison data, ground truthing on any of those products, let us know, Art. We'd love to see how that comes through since we're in the hourly weather data business as well.
Yes, you are. Yes, you are.
Oh, fantastic. And I'm sorry, one more question just popped in here from Ken I want to get to since we have a minute. Ken's curious, do you work with clients on interpreting the data that you provide? So that's an interesting one. Like how far do you go beyond, the, I guess, analysis, I guess, of that data that you provide?
Yeah, I would say that depends from case to case. I mean, clearly, you know, we do answer the phone still or answer email, so a lot of interpretation there. Would say a lot of the interpretation is with the clients we're building these products for. So there's a lot of give and take and back and forth in that. We do a lot of outreach, webinars to different groups, different ag groups, farmer groups, and things like that. And there, that's where we do a lot of our interpretation and things like that. Um, clearly one of the cool things about being a climate center is, we're not afraid to talk to people, and a lot of our ideas for products and things like that come, for giving a webinar like this, and somebody might email me and say, look at, this is what I'm interested in, or this is my application, and quite often, that's how one of our products are born.
Oh, I love it. Well, you certainly have the data. People have the problems, and they can come to you to help find a solution backed by that data. So that's a beautiful thing.
Yes, it is.
Well, I really appreciate you giving your time, sharing your expertise tonight. Really thankful for what you and the folks do at the Northeast Regional Climate Center. Really appreciate all the services that you provide there. And grateful for everyone else who's joined tonight's program. It is a free program. We do strongly encourage you to make a donation to help support programs like these to keep them free over at mountwashington.org. You can find the donate button there in the upper right-hand corner. If you have thoughts for myself or for Art from tonight's program or suggestions for future programs, please take some time to fill out the Google Form survey that'll show up in the Zoom window following this program, and also in a thank you email as well if you join through Zoom. And then finally, don't forget to join us for next month's Science in the Mountains program. That'll happen on Tuesday, February 11th, when we'll be joined by forensic meteorologist Alicia Wasula, who's going to be teaching us all about the history and science of forensic meteorology. And then in March, on Tuesday 11th, we'll have research scientist Megan Collins from the Desert Research Institute, who's going to be sharing all about the Mountain Rain or Snow Citizen Science Program. So we hope you'll join us for those programs or watch any of the programs you may have missed over at mountwashington.org. And we'll see you all again soon. Thanks again, Art. Hope you have a great night, and we'll talk soon. Take care. Bye-bye.